Good morning, this is Mr. Zanaletta. We're going to go ahead and go over topic 25 notes, angle arc relations in circles. It's our second week of giving you some new material. Hope you did well last week. Just like last week, we're going to go ahead and finish off the week with an e-cart. But initially, we got the notes, we got the homework worksheet, and I wanted to go over the notes initially. So one of the most important things here is the key idea: angle measures can be determined in different ways depending on the location of the vertex. And obviously, that's the vertex of this given angle. Some important terms: we sometimes have a tangent line, touches the circle at one point. So in this case, we're talking about this circle is touched by this bottom of this rectangular box. This would be part of a tangent line. And then from there, we can also go into secant. Secant touches the circle 2 points and goes through the circle. Which side is a secant? It would be this far right side of this rectangle, because it touches in 2 and actually passes through it. This would be your secant line. Once we get those terms down and the idea that the vertex is going to determine how we might be able to come up with angle and arc measures, we're going to go ahead and move into this whole idea of the central angle. A measurement of a minor arc, for that matter, the arc that relates to the central angle is always going to be equal to the measure of its angle, central angle relationships. So, with regards to this, the measurement of the minor arc, the vertex is the center of the circle. Here we're talking about the vertex. Is the actual center. Of the circle. Again, we're always really interested in where the vertex is. So in this case, when we have this vertex being right in the center, we're going to be trying to find the measure of that arc. And that arc is going to have the same measure of 70 degrees. Let me finish my formula over here. The central angle measure equals the arc measure. That's what I just did here on this first example. The central angle was equal to the angle measure and the arc measure. We're going to have the same thing here. We have this arc measure. We're going to go back the other way, and we're going to say that this angle measure will equal the same as the arc measure. The arc measure was given to be 200 degrees. This angle measure is going to be 200 degrees. That happens the same here with the minor arc. We have that arc measure. Arc measure is 10 degrees. So the angle measure right there is going to be also 10 degrees. That's the relationship between the central angle and the arc measure. They're going to be actually equal to each other. From there, we go ahead and go to inscribed angles. Now, inscribed angles are when the vertex is on the circle. And here they say the measure of an inscribed angle is half the measure of its intercepted arc. And really what I'm going to want you to do, we're going to change this up this year a little bit, and we're going to take that inscribed angle measure and we're going to multiply it by 2. It's going to be double the inscribed angle is going to be equal to the measure of the intercepted arc. So we're doubling the angle measure, and that should equal the arc measure. So in this case, this first one here, we have 40 degrees for the angle measure. Well, remember, here we're doubling the angle measure. So we're going to double angle measure is 40. That should equal the arc measure. And remember, the arc measure is this intercepted arc measure. So how big is that? That's going to be double this, which is going to be 80 degrees. And if you think about it, if you push this back out to the middle, that's going to be a bigger angle. As you push this vertex back to the center, remember this is equal to the central angle, that's the reason why we double the angle measure when we have a vertex on the circle. Let's go to the next one. The next one, here we're given the arc measure. So what we're looking for is x. I'm going to go ahead and take this. I'm looking for the angle, so I'm going to call that x. 2x, 2 times the angle equals the arc. Divide by 2, you get x equals 90 degrees. So that makes this 90 degrees. This arc measure is half of that angle measure. Actually, I'm sorry, the angle measure is half of the arc. The angle measure is half of the arc. When we set it up by 2, double the angle equals the arc measure. Do the same thing on this next problem. We have the arc measure given to be 40 degrees. We're looking for the angle measure. That angle will be 2 times the angle equals the arc. Divide by 2, x equals 20. So this is 20 degrees. In our last example here is, if this is 30 degrees, what's the arc going to be? Well, if this is 30 degrees, this is going to be a two-step thing I'm going to do here. This angle equals that arc. Well, 2 times that angle equals the arc. So that x is going to equal 60. That's the missing arc measure. Now my next step is going to be to go ahead and say, okay, now what's this angle measure? Well, the angle measures, we double the angle, and that's going to equal the arc. Divide by 2 and you get y equals 30. So there it is. The angle is 30 degrees. Well, it's the same as this. That makes sense because they're intercepting the same arc and they're both inscribed on the circle. So you may not have to do that math to get this answer in the future, but it does support it. This 30 makes that arc 60. That arc's being 60 makes this angle 30. Let's go to the back. Got 2 more situations where here we have vertex outside. The measure of the angle formed by the 2 lines of the intersected inscribed circle is half the difference of the measures of the intercepted arc. So in this case, we want to make sure they talk about the half again, and we've changed this up a little bit, so I want to make sure that everyone understands the measure of the angle. And that angle we're going to double again. Double the measure of the angle formed by the two lines that intersect the inscribed circle is the difference of the measures of the intercepted arcs. So we have two arcs that are being intercepted here. We have two arcs being intercepted here. We have one arc here and one arc here. And we're going to take the difference of those to equal the double of the angle. And again, we're just going to stick with doubling the angle here. Here we have a situation where the vertex of the angle we're talking about is outside the circle. That's when the vertex is out. And when the vertex is out, we double the angle measure, and when it's outside, we subtract the arcs. So when it's outside, we subtract the arcs. So in this case, on this problem right here, we're going to double what we want, 2x equals the arc minus the arc, 80 minus 20. Well, then that's going to be 2x equals 60, so x equals 30. So this angle is 30 degrees. In this case, next one, we want this arc measure from here to here is what we're looking for. The other arc that they gave us was from here. Let me see here. How do I mark this? The other arc that they're giving us is from here to here is the 150, and there's my angle. Well, what do we do with the angle? We always double the angle. So when I want this, I want 2 times the angle's 40 degrees equals arc minus arc, 150 minus what I'm looking for. So that means 80 equal to 150 minus x. Add x to both sides. X plus 80 equals 150. Subtract 80 from both sides, you get 70 degrees. So there's our answer. X equals 70 degrees. And again, double the angle equals the difference of the two arcs. Next one, two tangents. These are both tangents. This was one secant and one tangent. These were both secants. So in this case, with two tangents, we still have the vertex outside the circle. We're still following the same rule. We have one arc being from here to here. That's the 261. And we're not given either of the other two. How's that going to work? Well, before we get started, can we solve for one of these two? Well, if this is the pink is the 261, we're looking for this blue arc that I'm going to highlight in blue. It's that. Well, if that's 261, that's got to be 99 because this all has to add up to 360. 261 plus x has to equal 360. Subtract 261 from both sides. X equals 99. And once I have that, now I can use that formula we've been using all along. So I'm going to go ahead and set up that formula to solve for this angle measure right here is what I'm trying to find. That angle measure. That angle measure is going to be 2x equals 261 minus 99. 261 minus 99, that gives us 2x equals 162. Half of that, divide both sides by 2, and you get 81. So this is 81 degrees. Okay, vertex inside the circle. We're going to change up things a little bit here. And we're going to go over to vertex in. That means the vertex is inside the circle, not necessarily the center. It would work on the center, but then we'd have to have other measures. And the center, if we know it's the center, we don't bother with this. But the vertex inside the circle, like this first picture right here, the vertex is inside the circle. In this case, the measure of the angle, and again we're going to double this so we don't have to take the half of the other. The measure of the angle doubled, formed by two lines that intersect the inside of the circle, is half this, not half, it's going to be the sum of the measures of the intercepted arcs because we're doubling both sides. So we have 2 times the angle measure equals arc plus arc. The sum of the measures of the intercepted arcs, arc plus arc. And in this case, we're looking for one of these two angles, this one or this one. Those are the two angles, they're vertical angles, so they're going to be the same. And we want to double that angle, that's what we're missing. So I'm going to say 2x equals the sum of these. So 2x equals this intercepted arc plus this intercepted arc, 40 plus 70. That's 2x equals 110, so x equals 55. Both those angles would be 55 degrees. Here on the next example we have both of these are 35 degrees. We're looking for this measurement of this arc right here. We were given this arc, and we know this angle measure that's intercepting those two. So double the angle, 2 times 35 equals the sum of these two, 50 plus x. 70 equals 50 plus x. Subtract 50 from both sides, you get 20. So this has to be, this arc has to be 20 degrees. Next one. Again, double the angle. Double the angle. So we have the angle here. We're going to double the angle, 2 times 100. Is going to equal the sum of this plus this is where we're looking for. This is what we're looking for. So 2 times 100 equals 120 plus x. That's 200 equals 120 plus x. Subtract 120 from both sides. X must be 80. So this is 80 degrees. And that's when the vertex is inside the circle. The vertex here was inside the circle. One last little rule. Quadrilaterals, opposite angles of a quadrilateral inscribed in a circle, are supplementary. So here, when we say the opposite angles of a quadrilateral inscribed, means the vertices are on the circle. That's what it means to be inscribed, are on the circle. Once we know that, we know that opposite angles opposite angle measures, add